Hello everyone, my name is Taisir Muhammad Farooq and I'm studying in 6th semester. So today my topic is predictive parsing table. So without any further ado, let's understand what do you mean by a predictive parsing table, and we will be subsequently solving a problem. So predictive parsing table is a recursive descent parser which has the capability to predict which production is to be used to replace the input string. So we have a couple of steps which has to be followed to construct a table. So we generally have three steps. So the first step is to eliminate the left recursion and the left factoring, and we have to perform the left factoring. And then in the step two, we have the computation of first, and then we have to compute the follow function. So in the first step, we have to do few elimination. So we will be looking at an example and we will be learning about it. So in the elimination of left recursion, we have an example which stands for A tends to A, and then we have alpha or beta. So we can rewrite this as A tends to beta alpha dash. So then alpha dash can be said as alpha A dash or epsilon. So this is how left recursion is actually performed. So like the non-terminal nodes are replaced with A dash, and then subsequently we will be giving a definition to A dash. So this is how the step one actually works for the predictive parsing table. And then we have the first and follow functions. And for this, we will be looking at few rules for the first function. If x is a terminal, so the first and follow step, we have a few rules which has to be followed. And in the first rule, if x is a terminal, then first x is equals to x. And if it is a non-terminal, then we have to add epsilon to the first x, and x will tend to epsilon. So then if x is a non-terminal and x tends to A is a prediction, then add A to first of x. So this is how the first rules actually work. So then we have the rule, if S is a start symbol, then follow of S contains dollar. And then S stands for follow of S, which tends to dollar. And then A tends to alpha, beta, B. Then follow B will be the first of B. Then if first of B is not having epsilon. If A tends to alpha, beta, and B, then the follow of B will be follow of A. So these are the simple rules which we have to understand before going to the problem. Then we have a small question which we can solve to understand the first and follow everything in detail. So we have a question. E stands to T E dash, and E dash tends to plus T E dash or epsilon, and then we have a set of five grammar which we can try. So first of E is first of T. Okay, so like if we look at the first of E, then we have T here. So then T will be going here. Then the first of T is first of F. What is the first of F here? We can see that first of F is open parenthesis and ID. So this is how it has to be solved. And then we have, like, subsequently we have a first of T. First of T will be first of F, and first of F will be open parenthesis and ID. So then first of T dash will be star and epsilon, and the first of F will be open parenthesis and ID. So this is how it all works. So first is already solved, and now we will be going to the next function, which is the follow one. So then we have follow of E is dollar and closing parenthesis. Follow of E dash is dollar and closing parenthesis. Then follow of T is plus dollar and closing parenthesis, and then follow of T is plus dollar and closing parenthesis, and then subsequently we have follow of F is a star plus and dollar. So this is how the follow actually works. And now we can see the parsing table. We have the a table, and then for E stands to T E dash, we have the first and follow, which we have calculated in the last example, and then the same table is actually made for every grammar, and then this is pretty much self-explanatory, and then we have a pretty much wash table for the first. And then this is actually epsilon. You can just change it to epsilon. And then we have the grammar, which is actually rewritten from here. And wherever it is given, we have like wherever ID is used, we are putting E tends to T E dash. And then because we are having open parentheses, and in the place of an open parenthesis, we are giving E tends to TE dash, and then subsequently for everything, for all the steps, we are inputting and making the predictive parser table. So, like for example, if we look at the F tends to ID open parenthesis E closed parenthesis, we have ID open parenthesis. So, like for everywhere in the first function, we are giving ID and open parenthesis. For ID and open parenthesis, we have given. So, like we are solving for everything, and the predictive parser table is solved, and then you can have the correct answer. So this is how it all works, the predictive parsing table. Thank you for watching my video.